What are acids and bases? And we're going to take this in order of classification, right? So we started with Arrhenius, then Bronsted-Lowry, and then Lewis, and we kept expanding the definition to include reality. So Arrhenius said an acid was a substance that produces hydrogen plus ions in an aqueous solution. Bronsted-Lowry expanded that by saying it's a substance that donates H plus ions in aqueous solutions. And finally, we have Lewis, where we have it's a substance that's accepting an electron pair. We go over to the bases. Arrhenius produces OH minus ions. This was generalized by Bronsted-Lowry to a substance that accepts H plus ions in an aqueous solution. And then finally, Lewis, it's an electron pair donor. Here's two discussion points, which if you're with other folks, you can talk about it, or if you're with yourself, kind of write down an answer here. So take a few seconds or minutes. We'll pull out the answer tab when you're ready. Okay, here we go. The Arrhenius definition does not explain why a substance without a hydroxide ion is basic in solution, so that's why it was limiting. And then Bronsted-Lowry acids must have a hydrogen atom, whereas the Lewis acids do not, so that's the difference there. This is a great picture showing the evolution of the models. The Arrhenius and Bronsted-Lowry definitions, a proton can also be an electron pair acceptor, and bases such as water and ammonia are also electron pair donors. An acid is an electron pair acceptor. This incorporates both the Bronsted-Lowry and Arrhenius models, and a base is an electron pair donor. This also incorporates both the older models. So you can see how the Lewis model is kind of on the outside of this little diagram. It includes all of the Bronsted and Arrhenius acids and bases.